Okay, where's the starting point? What do I have to determine or calculate first before I even look at the difference quotient? That's it. That's another very important concept that you learned, I know you learned in this class. How to observe a function and say, oh, I know the pattern. This one says f of blah equals blah plus 2 over blah minus 4. And blah can be anything you want. And it turns out that my blah now is x plus h. Okay, so that's very important to identify the function like that. So this is x plus h plus 2, x plus h minus 4. Now I'm ready to put all three pieces together. What three pieces? 1, 2, 3. Okay, so let's put them together. Oops. These complex rational expressions are not trivial. So this problem I do not consider an easy problem. Okay, but if you're careful, when you replace x plus h plus 2 over x plus h minus 4 minus x plus 2 over x minus 4 and divided by h. So this is a difference quotient. And I know now that my next step has to be where?
Lowest common denominator.
Right. I have to find the least common denominator at the top. And h in the denominator becomes h over 1, which is the same thing. But I'm preparing it for flipping it. That's why I wrote it as h over 1. So now remember, these two have 0 factors in common.
Right.
So it's like 2 and 3. What is the least common denominator? It's 2 times 3. Yeah. Same thing here. X plus h minus 4 and x minus 4 have nothing in common. So it must be the product of x minus 4 and x plus h minus 4. It's not important if you put x plus h minus 4 first and x minus 4 second. However, this is the correct sequence. Now, I know what I need to multiply the top of the first one by, and I know what I need to multiply the top of the second one by. Exactly what it does not have in the denominator. This one does not have x minus 4, I'm sorry. Has to be multiplied by x minus 4. And this one doesn't have the other one, which is x plus h minus 4. Now, in whatever order you want, dictate the numerator.
X squared.
Yes. So I'm distributing x to these three terms. Very good. X squared. If you can alternate, if that's what you want, it's fine too, Stephen. So what I would have done, I would have multiplied x by these 3, and I'm done, and then I will distribute negative 4 to these 3.
Okay.
Only because I prefer starting with the smaller of the two, meaning with the binomial. I will distribute easier the binomial than distributing the trinomial because I may forget the last term, or who knows.
Okay. Do it that way.
So, but if you're used to, don't change your method if it works for you. So x squared plus xh plus 2x minus 4x minus 4h minus 8. Is this okay? So x squared plus xh plus 2, x, and negative 4 times x, negative 4 times h, negative 4 times 2. Is this okay?
Mm-hmm.
Now careful here, because I have a negative x that I distribute to these three terms, and a negative 2 that I distribute to these three terms. So
Negative x squared, or minus x squared minus xh plus 4x.
very good. Now I distribute negative 2.
Yeah, minus 2x minus 2h plus 8.
That's it. Now, what has to happen before we even look at it? What has to happen every time we determine the difference quotient for any function on the planet? What has to happen? Two things have to happen. First one,
You have to end up with at least one h.
Or
No?
everything without an h has to go away?
Exactly. Because of the second thing that has to happen. The terms at the top have to, the remaining terms at the top have to have h, because I have to pull it out so that I can kill the h in the denominator. So these two are connected. Number one, everything that does not have h in the numerator has to go away. And the terms that have h will be factored, we will factor out an h from them and simplify with the h from the bottom. So let's see what we can eliminate. A positive x squared with a negative x squared, a positive 2x with a negative 2x, a negative 4x with a positive 4x, a negative 8 with a positive 8. It happens that also xh with negative xh go away. That's fine. But definitely at least the terms without h must go away. So what is left? I see a term here right in the middle, and I see another term here right in the middle. So the top fraction is,
Negative 6h.
yes, and I already write it like this. Negative 6h over x minus 4 times x plus h minus 4 multiplied by 1 over h. To save time and paper and writing. And so once I fully simplified the numerator, I write it as negative 6h divided by its denominator multiplied by 1 over h. And that's how we get rid of this. And you'll see what happens in Calc 1. It's basically a limit. So this is negative 6 divided by x minus 4, x plus h minus 4. What is this? You will see in the next class. Is the rate of change of a function at any point where the function is defined. Because remember how we determined this? From x comma f of x and x plus h comma f of x plus h. So it's the slope of this line passing through x comma f of x and the other point x plus h comma f of x plus h. It's the rate of change of the function between these 2 points. So this gives the rate of change of the function at any point where the function is defined. Okay, the next problem. What about number 7?
Sound good.
F of x equals log base 5 of x plus 10 over x plus 7.
Look for restrictions.
Yes. How many?
2.
Exactly. You remember because this is the only problem you messed up.
Oh, did I mess this up? Ah,
That was the only one you did.
oh man. This looks so easy right now.
I-
Must have been stressed out.
I know.
X plus 10 has to be greater than 0. And x plus 7 cannot be 0.
That's it. So let's determine the domain.
X cannot equal to negative 7.
Correct.
Yeah, and then x plus 10 is greater. So x greater than negative 10. So then the domain is negative 10 to negative 7 union negative 7 to infinity.
Now see, I see already algebraic maturity, right? We don't need to write everything. We can see things now. We have developed our understanding of functions and intervals and domain and a lot. Anything else that catches your eye? If not, we can find other problems from anything else that you can think of. If there is nothing else that catches your eye here, or you know everything else. Is there any particular type of problem that you may have questions on?
Let's do 11.
Let's do 11. 11. 11. So the following triangle, very good. I have ABC, and we are given C, which is 42 degrees. We are given B, which is 40, and we are given C, which is 38. Oh, side angle. Okay,
This is where we can end up with 2.
yes,
Or 1 or nothing.
exactly. This is the only ambiguous case, the only one that can have 3 different options.
All right.
Okay, I'll make sure it's not going to be on the final. Thank you. Okay. So, how do I start? What do I apply?
And 2 common.
No, not yet. I have to write law of sines.
Oh, okay.
So, sine A divided by A
Right.
equals sine B divided by 40 equals sine 42 degrees divided by 38. And I know exactly where is the starting point now. By simply looking at these proportions, I know exactly where I have to be. Right.
last 2.
Right. This is the only chance because here I have 2 variables. I can't.
Right.
So then I have to find that sine B equals 40 multiplied by sine 42 degrees over 38. So what is sine B?
About 0.704. Sorry. Yeah.
Yeah.
Because that's yeah. And then,
You're sure that
Oh, apply sine. You apply sine inverse to apply sine inverse. To
I just
everything.
wanted to know for sure that you were in degree mode.
Yeah, I just checked.
Okay. So it's 0.7?
Yeah.
Okay, very good. So then from here we will determine B to be
It's about 44.78 degrees.
okay, very good. So if this is 44, I'm going to call it B1. What could be B2? Exactly. Exactly. 180 minus B1. So that's B2, which is
135.52.
Very good. So now indeed I know triangle 1, number 1 and number 2. I will write uppercase A1, uppercase B1, which is 44.78. I will write C, which is same in both. So A2 and B2, you gave me 135.52. C is the same, 42 degrees. No one can change C. Little A1 is unknown. We'll have to determine it. And A2. And B and C are the same. So B equals 40 and C equals 38. B equals 40 and C equals 38. So I have to determine A1 and A2. How will I determine A1? From 180, I subtract
Yep.
42, and I subtract 44.78, done?
Yeah.
Okay.
And we get A.
And how much is A?
93.22.
93.22. And then A2, from 180 I subtract 135.52 and I subtract 42.
2.48.
Good. With this information I go back,
Apply the law sign.
this time here. This, so now I have sine, so sine 93.22 over A1 equals sine 42 degrees over 38. And then I have sine 2.48 degrees over A2 equals sine 42 degrees over 38. And that's how I determine A1, lower A1, lowercase a1, lowercase a2. So from here, A1 will be 38 sine 93.22 degrees divided by sine 42 degrees. So it's this times this over this because I'm determining A1. And then I'm determining A2, this times this over this. So 38 sine 2.48 degrees over sine 42 degrees. Any questions? Next problem. So do we have A1 and A2?
A1's 56.7.
56.7 and A2?
2.46.
Lowercase a2, not this one. You gave me the,
Yeah.
okay,
That's
Right.
what it is.
that's it?
Yep.
It is what it is. Perfect,
It's just really close.
good. That's my chance, of course.
Yeah.
Okay. Next problem. We'll see if anything catches your eye from this test. And we'll tell you whether we did it or not. And if we did, we're gonna make you do it. Just kidding. How would you graph 21? X squared minus y squared equals 4.
That's a circle.
The circle cannot have minus. There is only one out of 4 conic sections that has minus.
Just
I know. So what do I have to do first?
divide by 4.
Exactly. So then I have x squared over 4 minus y squared over 4 equals 1.
Start at the vertex at 0, 0, so start, or it starts at 0, 0, so go up 2, up 2, right 2.
Yes. Good. So So that's the center box. Since you can say, okay, but I could graph it this way, or I could graph it this way. No, it all depends where the negative is. So if the negative is in front of y, it's this.
Right.
If the negative is in front of x, then it's this. Okay, not to get confused there. Good. Then I will draw the asymptotes, and they have to go to this corner, the origin, and this corner. It turns out that these asymptotes have what equation?
Y equals x and y equals negative x.
That's it. Good. And now we are ready to graph. Here it is. So this is a hyperbola, and the equation is here. What about the extra credit, 23?
How are you?
Or you have something else in mind?
Yeah, let's do that.
Good. So x squared. Squared minus 9y squared plus 90y plus 2x equals 624. Which conic section or conic sections this equation cannot be for sure?
A circle.
Yes, it cannot be a circle. A circle cannot have minus 9 in front of y squared. Okay, what else it cannot be for sure? So let's look here. So obviously it cannot be a circle.
Yeah.
What else it cannot be? So here we have an x squared and we have a y. I cannot have an x squared and y squared. Here I have a y squared. I cannot have x squared. So there is an x squared and there is a y squared.
Yeah.
So it cannot be a problem. Absolutely. So it cannot be a circle and it cannot be a parabola. So what can it be? If it is a conic section, it can be an ellipse or a hyperbola. So I know what to expect. Good. First step. Yes, I will complete the square for x squared and 2x. What do I need to add to both sides? It's basically from the agreement, but when we signed the agreement, we didn't think in these terms.
X squared plus 2x plus 1.
That's it. So I have to add 1 to both sides. And then I have your x plus 1 squared, right? So this is accounted for. All these are in there. X plus 1, everything squared. Everything is in there. Now, it's a little bit more difficult with y. Why it's more difficult with y? Because of this negative 9. So I have to pull out a negative 9. And I have a y squared, and I have a negative 10y. And inside I have to add and subtract. Indeed. negative 5 squared 25 and negative 25. Very good, awesome. So then I have at the x plus 1 squared, I have the 9. I have in parentheses y minus 5 squared, and then I have to multiply negative 5 by negative 25. Negative 9 by negative 25. So positive 9 multiplied by 25 equals 625. Is this step clear? So then I have x plus 1 squared minus 9, x minus y minus 5 squared. And then this is 225. 625 minus 225 equals 400.
Did you add the 1 on the left side?
Yes, 624 plus 1.
Oh, great.
It's very clear what it will come out to be because of the negative in front here. What will it be? It will definitely be not an ellipse,
Hyperbola.
but hyperbola. Good.
Yeah.
How do I continue? Divide by 400. So I have x plus 1 squared over 400 minus y minus 5 squared over 400 divided by 9 equals 1. We're not asked to graph. It's definitely on the transversal axis on the x-axis or on the y-axis?
Goes like this.
Yes, on the x-axis. Very good. So can anyone give us the center? Because it's a shifted conic section. It's a hyperbola.
Negative 1, positive 5.
Negative 1, positive 5. Awesome. And can anyone just give us a and b? A will be the square root of this, 20. And b will be the square root of this, which is 20 divided by 3. Very good. Awesome. Anything else that you would like to go back to? Or anything that you can think of and say, I would like to review? The trig identity, if you want, on problem 15, or trig equation 16.
Yeah, can we do 16?
Yes. Okay, so let's continue with 16. 2 sine squared minus 5 sine x plus 2. Yes, I know it's a trig equation. What do I do? What do I have to do first? After I identify that it's a trig equation, I have to say, well, actually it's quadratic as well.
Mhm.
And I have to factor based on sine x. Or solve for sine x first, and then solve for x. I cannot directly solve for x. I have to solve for sine, and then for x.
You factor
Yes. How can I factor this?
2 sin x minus 1 sin x minus 2.
Okay, so let's check. 2 sine x, some sine x is 2 sine squared. This is negative 2 minus 1 is negative 5, and negative 1 times negative 2 is 2. Clear. Perfect. Very good. Now I'm able to solve for sine. So let's solve for sine. How many solutions will you give in sine?
2.
2, of course. It's quadratic in sine, right? So sine x equals, yes, from here. Very good. And then sine x equals, good. So let's start with sine x equals 2. What do I do to this one?
Sin x is equal to 2.
Yes.
Apply sine inverse.
Okay. Let's apply sine inverse.
So sine inverse of 2 is x.
How big can sine be for any angle on the planet?
1.
1. So let's apply sine inverse to it. Does it? That does it. That does it. I'm going to torture you with this for the next 10 minutes. Okay, let's apply
Yeah.
second sine inverse to 2. What am I going to get?
You're gonna get it
Obviously, the calculator's wrong.
here.
Of course it is.
Software.
Of course it is. So no solutions.
Right.
Remember, maximum sine is 1. What is minimum sine?
0. Love it. Negative.
Let's go back to the blue one.
Good, -1. What is cosine maximum possible? Yes, what is the minimum cosine possible?
-1.
Correct.
No comment.
Good. So now this one has 2 options because sine is 1/2 in 2 quadrants.
Right.
So sine equals 1/2. I know exactly which angle has sine 1/2. Very good. So here's what I do. Right here in the middle, I draw a horizontal line. It crosses the circle in 2 points, and these will be the terminal sides of the 2 angles whose sine is 1/2. Indeed, the first one is pi/6 plus 2 pi k because the period of sine is 2 pi, where I have to write 0 plus or minus 1 plus or minus 2 ... And then the other one is
5 pi over 6. plus
Perfect.
5 k.
perfect. You don't have to write it twice. Once you write what k is once, you don't have to repeat it.
Or they just write K's in it.
Just once. Yeah, very good. Perfect. Anything else from here or anything else that you would like to review? Yeah, let's look at let's look at 22, A, B, C, unless you have something else in mind.
Let's keep going.
Okay, good. So let's look at 22A. In 22A, we are only asked to punch it in the graphing calculator. You have 2 options. So a sum from I equals 6 to 9 from I and I plus 3.
Are we gonna have one on the final where we have to do that quick calculator?
You don't have, yeah, but you don't really have to.
Oh, okay.
You know, it's not going to be something.
I have the old calculator, so I have to do it the hard way.
Oh, you can use mine.
Oh, okay.
That's no problem. So you can write 6 multiplied by 9 plus 7 multiplied by 10 plus 8 multiplied by 11 plus 9 multiplied by 12, and just multiply them. Or you use the sum of the sequence. So sum, in parentheses, sequence, and you have that shortcut that you came up with last time in list.
Right, that's right.
That was a very, very good idea. So with the second and list, go to math, and let's do this. So it's the sum, which is number 5,
Yeah.
and then we go back to second and list and choosing OPS number 5. So it's very quick. No, I didn't mean that. Not sure why it doesn't. Did you allow you when you did you allow it?
Yeah, mine puts it.
Okay. I don't know why this doesn't. Anyway. Okay, sum of the sequence in this case, you can write it, and it's safer and easier as I squared plus 3I, comma, from, so you have to put I, the calculator will put N, right?
Right.
Or X, not I, sorry. So X is the variable in the problem. It goes from 6 to 9 by 1. And don't forget to close, although it will probably work without closing both parentheses, but it's safer this way. And then it will calculate for you the 6 times 9 plus 7 times 10 plus 8 times 11 plus 9 times 12. With x squared plus 3x, comma x, comma 6, comma 9, comma 1. Or you use the sigma notation. Steven, are you okay with this?
Yeah, I got 320. Yeah.
We all got 320?
Mhm.
Okay, perfect. Part B then. 1 minus 1/2 plus 1/4 minus 1/8 plus dot, dot, dot. Determine if the infinite geometric series is convergent or divergent. When is an infinite geometric series convergent? Only when
Absolute values.
of the common ratio is less than 1. Very good. So let's identify what the common ratio is. 1 was multiplied by what to get 1/2? 1/2. 1/2 was multiplied by what to get 1/4? Right. However, from here, it was negative 1/2. From here was still negative 1/2. From here was still negative 1/2, and so on and so forth. But you're right. It's the common ratio in absolute value that has to be less than 1. And it is. Negative 1/2 in absolute value is less than 1. So what do I conclude about this geometric series? Infinite geometric series.
Converted.
It is convergent. And let's determine the sum. The sum is S, which is A divided by 1 minus R for the infinite geometric series. So A is 1 over 1 minus negative 1/2, which is plus 1/2. 1/2 plus 1 is 3/2, and I have to flip. So this is 2/3. Can anyone give us the nth term here? Remember, it has to be A multiplied by R raised to n minus 1. How much is A? 1. Multiplied by negative 1/2 raised to n minus 1. That'll be the nth term of the geometric sequence. So negative 1/2 raised to n minus 1. I like to plug this in, just for the sake of the argument, as negative 0.5, close, caret, in parentheses, x minus 1. And now I want to go to second and table set, and you know I have to change all the time. And second to and table. And I want to calculate any term you want, if you need to. Or I can create also the sum. Can create the sum. So you can say, okay, let's say for 1, 2, 3, 4. Let's say for 4, I should get negative 0.125, which is negative 1 over 8. But if I want to determine the sum, go to math. Okay. And x equals 1 through, I want to check my 2/3, but I cannot put infinite in there. Calculator will not calculate with that. I'm going to say 99. I don't know if the calculator can do this or not. We'll see in a moment. So this is negative 0.5. Be very careful. In parentheses here, you have to put in parentheses, negative 0.5, close the parenthesis, caret, in parentheses, x minus 1, close the parenthesis, and then close the parenthesis, and then go outside. Okay? So this should be with 99 terms. I don't know how close to 2/3, but 2/3 is 0.67 roughly, right? So let's see how close we got. If I want to repeat and just change that upper limit, just a checkpoint, just to see what the calculator is giving. And if I change this to 2,000, I don't know if it's going to do it or not. I have no idea. Is it thinking? Yes, it's thinking. Look at that. I may have broke the computer. Oops.
There you go.
So now I know for sure that my 2/3 is definitely correct. Although I knew from the fact that it was an infinite geometric series, I determined the common ratio. It was convergent because the common ratio in absolute value was less than 1. I knew the formula. I plugged it in. But this is just reinforce it. Good. Next. Oh, yes. Yeah, we did see last time, I believe. Well, let's do it again. So we're asked to find the sum, which is 1 plus 2 plus 4 plus ... plus 16384. Now I have to identify, the first thing that I have to say to myself is, since there is no, like here, plus or minus ... I am not talking about a geometric series. It's a finite sequence, right? It starts with 1 and it ends with this. That's my first thing. It's not, so if I want to determine the sum and this is geometric, because if it's not geometric, I cannot use that formula for geometric if it's not geometric, okay? So if it is geometric, then I will use 1 minus r to the nth power over 1 minus r, but I have to determine whatever n, because I don't know what n is in here, right? I don't know how big. So first I have to identify whether it's a geometric series or a sequence, and it turns out to be, because it ends with a number, it's a finite geometric sequence. Secondly, I have to identify whether it's geometric or not. I should have not used the word geometric in my first question. So now I have to, so it's clearly that it's a finite sequence, not a series. Number two, is it geometric? I don't know. So as long as I can show that every term is obtained multiplying the previous one by the common ratio, then it is geometric. So 1 multiplied by
2.
and 2 multiplied by 2 is 4. So then I know that this must be something with 2 raised to a power. Okay? So this is definitely S sub n, which is 1. 1 minus the common ratio to the nth power over 1 minus 2. If this were a geometric series, I would have said not convergent. I cannot even determine its sum because the common ratio in absolute value is not less than 1, but more than 1. But I can determine the sum of a geometric sequence as long as it's finite, right? That's the concept. Okay, so now all I have to do is try to find 16384 as being is 2 to a certain number. And then I know this number will be also, because I would like to determine n. But you can say, okay, but do you really need to? You can just plug it in.
Right.
Because you have 2 to the n is this. Just plug it in and give me the sum. Fine, I accept that. So 2 raised to a power will be 2 to the nth. Because this has to be, if it's a geometric sequence, this has to be represented with the power of 2, with a base of 2 raised to a power. And then we can say, okay, I know how many terms I have. Now, if you want to calculate this with a graphing calculator, you need n. If you want to put it in, because otherwise the calculator will not. As you saw, I had to change 99 into 2000 if I wanted to calculate something with a graphing calculator. So we do know that 2 to the 10th from your experience in computer science is 1024. So if you raise 2 to the 10th power, then you know that that is 1024. We should know that number.
Yeah.
Okay. So then beyond that,
You could solve that by applying log to both sides, right?
fine, that's even better. Good. Because it's kind of difficult to come up with.
Yeah.
I agree. So natural log 16384 equals n multiplied by natural log 2.
Yeah,
So
the 4 and the 8 reverse, but yeah. 16384.
oh my goodness. How did I do that? Thank you so much. 16384 divided by natural log 2.
14.
How much?
14.
Very good. So n equals 14. So then S sub 14 is what we are really asked to find, which is 1 minus 2 to the 14th power, which we already know what it is. It's 16384 divided by 1 minus 2, which is a negative number. So 1, which is negative 1. So 1 minus 16384. So the answer would be 16383. I did something. What did I do? And to the 14th. That's what we got here, 14?
Yeah, checks out.
Yeah, 16383. No.
So,
So it's,
say it again.
why do you want to find the 14th term?
No, we are only asked to find the sum.
Yeah. Okay.
So, I want to do this. So from I equals 1, through, what was it? 14?
Yes.
Okay. So from x equals 1 through 14. Ah. So the sum, so this is when n is 1, this is when n is 2, this is when n is 3, and this term is 1 times r to n minus 1. So then n is 13. Careful. No mistake on your part. My mistake. I should have explained that.
Okay.
So n is 13, not 14. I mean, not it's n minus, not, I shouldn't say n is indeed 14, but it's 14 minus 1. So this term, so we're really asked to find, right? So we determined from equating, so that's why we have to do this again. Okay? Be careful. Not your fault. Mine. So 1 plus 2 plus 4 plus ... 1, 6, 3, 8, 4. This is when n equals 1, this is when n equals 2, and this is when n equals 3. And this is a multiplied by r to n minus 1. So we already established the fact that r is 2. We already established that a equals 1. So I will equate these two in the following way. So 2 raised to n minus 1 equals 1, 6, 3, 8, 4. Okay? Careful. So then we apply natural log. So we have n minus 1 natural log 2 equals natural log 1, 6, 3, 8, 4. So n minus 1 equals natural log 1, 6, 3, 8, 4 divided by natural log 2. And then n equals 1 plus natural log 1, 6, 3, 8, 4 divided by natural log 2. So this was 14. 14 plus 1 is 15. So when we determine S15, we have 1 minus r to the 15th power divided by 1 minus r.
Yeah.
Yes, so 1 minus 2 to the 15th power divided by negative 1. It would be a positive number. And then we'll check with the graphing calculator. So,
Yeah, that sounds good. 32,767.
32,767. So this is 32,767. And since we have this very elegant way of determining and checking stuff, so x equals 1 through 15. It doesn't allow me to go back. That's fine. It's frozen now. Ugh. Okay, it's not frozen. But I still would like to go back here. It won't allow me to. Okay, it did, finally. Okay, 15. And in parentheses, what do we have? We have 1, we have 2, right? 2 in parentheses, close. Power in parentheses again. What do I have? I have x minus 1, right?
Yeah.
Okay, I didn't have to do that. Okay, so here it is. So yes, always remember, when n is 1, n is 2, n is 3, ... a times r to n minus 1. Because when n is 1, r, thank you, sorry. So for this, when n is 1, r is raised to 1 minus 1, which is 0, r to 0 is 1. So careful on that, because I'm going to scan this. Maybe I shouldn't. Oh, I don't need to scan this. Okay. There's nothing here that pertains to a previous problem. Good, very good. Next question. Now, what would you like me to do on Wednesday? Would you review your tests 1, 2,
Yeah.
and come back and say, I would like to do more problems of this, more problems of that? The solutions are posted, and I will post solutions for test 3 when I finish here tonight, and I will have your grades by tonight, except Paul's, unless I run downstairs before they close. But I'm giving a test, and I will probably not be able to run downstairs.